run the let it run, and here
the self-test run, it is not necessary to connect it with the humidity control unit.
no. The humidity control unit is
out of
checked.
It's out of JP.
It's not
because
checked.
it's salt you bought mixed by yourself. So it is
At the IQ/OQ you test if it is correct, but in the self-test, no. So maybe better we are talking about the humidity control. Maybe in the laboratory you have seen there is a backpack on it with a bottle and with a solvent in there with salt, and the air is flowing through the ADC2, and so it is giving a certain humidity to the plate.
Okay.
So maybe did I show the video already from the ADC2? You know the videos that are available for ADC2? No. Okay, then we have quickly to go, because they are quite nice to understand what's happening, and so they are also quite new. So now I think temperature. What would you think?
We can get it with.
No, not now, because it's already in the motors. What do you think? Temperature?
20?
No, 20 is too low.
30? No?
24.
24 is also good. Humidity? That's difficult. 54, I would say. 6.5. But the thing is, I don't know in which direction. But anyway, it's not important. So it says just the rest is passed, and now it is measuring the line, so it's also passed. So these two things are yeah, but I don't have my telephone. It's strange because I switched my phone off to silent, I'm not here. Okay, so this is just the humidity sensor. What we can check it again afterwards. So what I wanted to maybe I quickly go to the internet. As always on our homepage, if you go to products, developing, automatic developing chamber.
Camag is the world.
So let's go to YouTube. I can't expand it.
In planar chromatography, and provides instruments, software, and consumables for all steps of the TLC HPTLC procedure. Chromatogram development is the heart of the HPTLC process. In the Camag Automatic Development Chamber ADC2, this step is fully automated and reproducible, independent of environmental effects. The activation of the plate, preconditioning, chamber saturation, developing distance, and final drying can be preset and monitored using the VisionCAT's HPTLC software. With its guided approach, VisionCATS effectively leads you through the entire chromatographic process, step by step. The ADC2 will automatically develop the plate, leaving the analyst free to do other work. The ADC2 provides development under controlled conditions. Open the front door, load the applied plate in the plate holder, and insert the plate into the automatic developing chamber.
now you will see how it is happening here.
Developing solvent for plate development and 25 milliliters of developing solvent for chamber saturation into the solvent ports. The entire process is monitored.
What's that really?
You want something
The
like
plate
this?
is developed in a saturated chamber using the default settings.
You see here also the salt, it's very important you have to have some salt.
Optional humidity
0.8 liter and
conditions, obtaining
now you see very good
results from plate to plate. Perform chromatography under different climatic conditions and compare chromatograms created in different labs of results obtained from different batches. Chromatography is started by lowering the plate into the developing solvent. During chromatography, the position of the solvent front is monitored. At the end, the developed plate is homogeneously dried in an airstream. All parameters are recorded in compliance with CGMP, CGLP as part of the analysis. After successful chromatogram development, just open the front door of the ADC2 and remove the developed plate for the next step of the Hptlc process.
So the intention is to have on all our products such videos. So we have on the ATS4 and on the ADC2.
It's around the world for the scanner and the visualizer.
Yeah.
Okay. Good, very, very good.
There you see that there are also others around for from Don here. You see, our American distributor, he did on his own, and now we said, okay, we have to do something more professional. We just start first with something not that good, and then we said, okay, so that was just about that. That is also on our homepage, so therefore. So now we go in rush quickly through the ADC2 topics. It's not important. Yeah, we are chromatogram development. So this is also marketing. The thing maybe which is really important, it is fully automatic developed 20 by 10 or 10 by 10 Hptlc glass plates or 20 by 10 alufoils and not 10 by 10 alufoils. The reason for that is our alufoil holder holds the foil down on the left and right side of the plate.
To avoid
And-
the curving.
Yeah, and if you have now a 10 by
10
10,
by 10.
you need it to have it in the middle,
Yeah.
and there it's not. And if the instrument is bringing the foil
Then-
down, it can happen that the foil is going like that, and then it is.
Yeah.
So therefore, it is not for 10 by 10 alufoils. Yeah, with this humidity control, you can control at least a bit the humidity. And there it is, I think it's not really the important thing that you get 35.7 percentage of humidity, relative humidity. It is important that it is always similar. No. As most of Hptlc or chemical things is, it has to be, the conditions have to be similar to get the reproducibility not only on the plate, you have to get the reproducibility in the whole world, mainly. But first you want to get it in your office or in your laboratory, so same temperature, same humidity, and for that is this humidity control to set one parameter at least the same. Temperature we cannot control, but we say, okay, in the laboratory there should be something like a normal temperature, but we had also customers, there was water dropping from the walls, and temperature was dropping in nights to really deep temperatures, and during daytime they had 25 or 30 degrees. So therefore, in such environment, to work in a qualitative or quantitative way, it's rather difficult. Then, that's also. So this is the the new one, which magnetic holder. You put it in. So just about. This is the activation drying chamber. So in the up chamber, the plate is activated. Means we set the humidity, and this also dried with the airstream. The twin trough chamber is a special chamber which is specially measured with this instrument, and you should always keep it with this instrument. If you have two, for sure customer will
change it.
The thing is not, but it can be that is 1 or 2 millimeters difference in the development. Therefore, there should be, if they have 2 ADC2s, they should mark them something like blue and red or whatever. Also, normal twin trough chambers, you can take them. It's no problem. So these ones, they have an ADC2, a small underneath. This doesn't have, because it was really one of the first one. But new ones, they have an ADC2, and if they take a normal one, also that it is working. But as the tank is not exactly at the same height as with the original one, it can be that the plate lowering is not exactly the same. Therefore, the humidity or the developing distance, it could be different. Could be different.
What about if the customer broke in the chamber and asked it to purchase a new one?
Yeah. You have then to get a new one. They are specially checked that there is no air bubbles in the glass, that they are clean, things like that. They also measured that they are.
We have
because
ADC2.
Yeah.
Yes, you
When
have
you
that
order,
cut. Yeah.
you have to specify.
Yes, you
Yeah,
have it.
exactly. It's a special number. And the thing is also here, it has to be reproducible. So therefore, if it is always the same, it is okay. I mean, the thing would be if they would have 2 chambers and they would switch. It could be, but it is really something like you really have to think about to tell a customer, okay, now you have switched. We don't know which one. So it's not. It is really a small influence, but it is an influence actually. So the 2 inlets we have already seen. It's more explaining how to use it. You can press run, then you do the last developments the instrument did, things like that. So this is more giving you an introduction into the instrument. Also here the humidity control, again to show that on the bottom there has to be some salt. Or if there is no salt, for sure it is going to the wrong humidity, because it's then it is not saturated, the salt. And here, just to show you the impact of humidity, is 18 tracks at 17. So you see 1, 2, 3, 4, and here you see a little. There is something strange. Then 18 tracks at 47, you see this one separated, and also here you see a slight difference. You see here that now 18 tracks at 75 relative humidity is like that. It is not always like that,
of course,
but it goes in this direction. So, and therefore, if you have different humidities, and see, if you have 1 times 17 and 1 times 47, what can happen? But in real world, you have 75 is inside is, but this can happen. So these 2 chromatograms, they look quite different. So this is the block diagram, which is also not that complicated. We have this main board here where all the ports are. New instruments, I don't know if you recognize them already. So new instruments do not have this Ethernet port, which this already not. It was a real first one. So here usually there is an Ethernet port until last year, and now we got rid of that. So there is no. It looked like that. The thing is, at 2006, Camag was thinking of get rid of the serial ports after serial ports we already talked about, and then we learned okay, maybe not that easy, and then now after 10 years we say yeah okay we won't change that, so we took it out. So if you now order a board, you have a hole at the back. So therefore we deliver a small plate you can put on. Then you have the switch panel on top for sure, then you have the twin trough chamber with the 2 valves. So sometimes it happens like that you get the information from the customer, it is taking very long for development, or even the instrument stops developing and says there is no development solid in there. The reason for that is most likely that here from the mobile phase, in the valve or from the tubing from the valve to the twin trough chamber, there is some dirt. So if the customer doesn't put these lids on or so, underneath here are the inputs here from this. So what we usually do is we take the air and open with the service mode. We open the
service mode,
and then we clean it like that. Then make sure that you have some cloth or paper, because sometimes it is really something. Instrument and desk is sometimes it depends. What also could be is that they say the same thing, but everything is good and fine, and then you see, you check the lids, and then you see that they are kept clean and nice, but they are somehow wet. And when they are wet, and you put them like that on, it gives vacuum with that together. And then first part of the solvent is going down, very good, and then if the vacuum is getting bigger and bigger, the resistance is getting bigger, and at the end the solvent is just kept in the reservoir, the rest. So you don't have all the solvent down there. So therefore sometimes we cut with a knife here, just that you have this airflow that can be flowing good. Yeah. Then we will see later on, there's the power supply, so there are 2 boards in there, the power supply and this control board. There is a really small board, which is the sensor board, keeping the temperature and humidity sensor, and the fan. The drying chamber is the chamber up here. Then there are the motors. The spindle motor is bringing this module in front, so you can have a laminar airflow around the TLC plate.
Well, we have 2 minutes to.
Oh yeah. Oh, very good. So okay, just quickly, and there is the motor for plate lift, so up down. So that's nothing big. Okay, so the CCD module we have. So there is a CCD module which is back. Okay, so I leave you now down. So left there.